We won't be doing super. I'll be pretty zoomed in, so, but I would say for the notes that'll come up here, yeah, it's probably good to follow along like on your own screen because it won't be too much. But the actual stuff we're doing, I'll be really zoomed in. Okay, so to get started here.
Okay, I was muted. Sorry about that. So actually, just an introduction first, since we have a lot of new people here, which is really great. So my name's Paige Swanson. I'm a software engineer. In particular, I'm like a full stack web developer for a company in Raleigh, North Carolina. So I work remotely, live here, hence why I'm here right now. And we started this digital instrument series to learn a little bit about audio programming, a little bit about audio in general, and a little bit about programming, kind of all at the same time. So that's the idea behind this. And of course, we're at Ives Squared right now, which is the kind of the technology center at the New Haven Free Public Library. So, okay. So getting started, again, sharing my screen now. Hopefully this can be seen on the Zoom. Yeah, okay, great. So these are the notes for today's session. We'll just be kind of going through these. The first part here is about working with Pure Data on the desktop. So Pure Data is the software we're using. Everyone at the library here has the software on the computer, like the library computers, but if you don't, you can either use you can follow these instructions if you want to, or like last session, we used a web version of the software. So I'll introduce that now really quick. I actually kept the link in the previous session. So if you just want a quick link, you can go to, oops, not that. You can go to, oh, it was that. You can go to the session 1 notes, this .md file. And if you just use this browser version link, open that up. It actually has to like wake up because it's like a cloud hosted application. So it takes a second for it to like get warmed up. But then once you get there, you can basically just follow along with the things that I'm doing. But everyone on the library computers or at home, if you get the software set up and installed, you can just use that. I would say the experience is a bit, or it's certainly smoother for the desktop software, but the web software works great for just kind of like on the fly. So I provided some like quick instructions for doing that. I'm not going to like walk through them because they take a little bit of time. But if you want to work on that, or use the web browser version in the meantime, and then you could follow up maybe and install the software, that works great. But I think the instructions are pretty good because the library was able to install it. The instructions. Right. Yeah. Oh yeah, that's right. So for people at the library, there should be a little thing called PD. There should be a little shortcut on there for you. And yeah, you should be able to use that. It should be on the desktop, I think. Okay, so I'll open my copy of PD so we can kind of take a quick tour just to get an idea of how everything looks. So I'll also zoom. Well, that's not really what I wanted. How do I? That's not what I wanted either. That's okay though. We'll just deal with it. Actually, I'm not going to deal with this. Oh man. I think if I. Well, okay. I guess this thing is just big now. Oh, maybe I can like. Oh, that made it even worse. Okay, well. Oh, duh. Okay, great. Okay, so this is pure data. It's an audio programming application. You don't really see much when you first open it. In fact, you can't really do anything at all because what you have to do is open a patch. So just a quick tour though before you open a patch. There's this log entry indicator here. This just basically helps you, like if you wanted to debug a patch, but we don't really got to get into that. One key part is this DSP checkbox here at the top right. So that indicates either that digital signal processing is on or off. I like to turn it off until I'm very sure that the sound I'm going to produce is not like going to be egregious, because that can definitely happen sometimes. So I usually turn DSP off until I'm like very certain that the sound is going to be at a comfortable level. But just something to note. What we're going to do is go to File up at the top left and do New. What this is going to do is open a new patch window. So everything you make in PD is going to be called a patch. And the idea is that basically we're going to build our instrument inside of this patch window. So last week we talked about kind of like the basics of PD and sort of how it works. I won't delve too much into that aspect of it because I have those notes available if you want to kind of look back. But what I will do is kind of walk through all of the tools that we're using at a minimum. So you can kind of, you'll still basically produce this instrument and know what's going on. But I definitely recommend taking a look back at those older notes so you can see like how things are actually functioning under the hood a little bit. Okay, so to start off, following these notes here, one of the concepts that is going to be basically the focus of using something like this software, pure data, is going to be audio. And when you create audio in pure data, there's not an immediate way for seeing like a representation of the audio you're creating. So as a quick example, I'm just going to draft a very, very basic audio object. And I'll kind of go through all of the motions for doing that. So just to kind of demonstrate how to get things into this patch. So I'm going to go to Put at the top, and I'm going to click Object. And the first object, first of all, I'm going to zoom in here. Okay, that's pretty zoomed in. Can I zoom in more? That's about as zoomed in. Okay, cool. So I'm going to make an OSC object, which is an oscillator. An oscillator is basically going to is a rapidly changing periodic value. And in particular, for pure data, it's going to give us something that produces an audio rate frequency. So we'll be able to hear it. So I'm going to create another object really quick, which is going to be a multiplier. So basically what I'm going to do, and when you see this tilde here, this little squiggly, if I could just have the same operator with just the multiplication, but that would just be for data. So like 1 times 2, 2 times 3. But if I want to do computation on audio, I use this little squiggly to indicate that like I'm working with audio. And an oscillator is producing audio, so I need to use this. I need to use this multiplication operator with the squiggly or the tilde to do that work. Now, why am I doing this? Well, I'm going to immediately before I produce the audio for the computer, you'll note if I turn on DSP, don't hear anything. And that's because I haven't sent it to the output yet. But the reason I'm multiplying the audio first is I want to attenuate it or bring it down because it's going to be really loud. And the way I'll do that is just do like a 0.2, or basically I'm saying scale the audio signal down by like 0.2. And for pure data, an oscillator is going to produce a wave at an amplitude of like 1. So if you're thinking of that, like relatively speaking, I meant just related to volume. So if max volume is 1, I want to do 20% of that. So that's why I'm doing this. But you'll see this pattern a ton. So it's just something to kind of get familiar with. And finally, we're going to create another object here. Put an object. And that's going to be called a DAC, a DAC. So that's a digital to analog converter. It's going to take this waveform and it's going to represent it for us physically. But really all it's doing is just telling our computer to route the audio to the output. So this is kind of a quick like rehearse of some of the stuff we did in the first session, but I think it's pretty good to review because it's pretty core. Okay, so now we should be able to hear the signal, except we're missing one key component, which is the frequency that the oscillator should operate at. So I haven't provided a frequency, so it's just basically still doing nothing. So I'm going to provide a frequency to this oscillator by using a number. I'm going to put a number here. So put again, and then select number. I'm just going to put that right here. And then I'm going to connect it. Everything in pure data, by the way, flows down. So inputs to things are on the top, outputs to things are on the bottom. All right, and what I'm going to do is I'm going to slowly raise this number. And you'll be able to hear it if you're here in the library. But hopefully if you're following along on Zoom, you can kind of reproduce this behavior. So I can just keep incrementally increasing this frequency and you'll hear the frequency increase. But you'll notice to kind of come back to this attenuator, it's very important because if I do this, pretty loud. And I can go to 1, make it a little. I started with 0.2. That's like just pretty safe. Oh, it just starts at 0 if you create this number object. And then what I'm doing here is I'm dragging the number by pressing command on my computer. But if you press control on your computer, you can drag this number. So just hold control and then click and drag. That'll change it. All right. So a lot of this is refresh, but the main reason I wanted to demonstrate this refresh is because one of the things we didn't tackle last week is like we're hearing a lot of different sounds and we're able to sort of represent changes in sound with this program or this patch, but we previously didn't really get a chance to visualize like what's happening, like sort of like what this waveform looks like what the audio looks like. If you've ever used like, you know, old audio software for like listening to music on your computer or something, or even if you've used like digital production, like media software, usually can see a waveform indicating like what your sound sort of looks like in 2D. So we're going to try to do that. And I'm going to stop the audio because it's a little annoying. And the way to do that is just, of course, clicking the DSP checkbox again. Okay. And I did do some shortcuts, by the way, to like adjust things. So I just want to make it clear, like I'm currently in edit mode. That's how I'm dragging things around and stuff like this. To go to edit mode, you just go to edit at the top and you can click edit mode. On my computer, it's also just Command E. But if you go to out of edit mode, what happens is now you're just interacting with the patch like it's an instrument. So I can't like change anything anymore. All I can do is interact with things that can be changed. Like this number happens to be interactive. I can change the number, but I can't like edit the patch. This is for like performance purposes. Like if an artist has like written this software to like use as an instrument in a live performance. They don't want to like accidentally edit it. That would be disastrous. So they just have this performance mode, so to speak. But I don't ever really leave edit mode. So I went back into edit mode just now, and like I said, just hold Control or Command, and then click items to interact with them normally. So, all right. So what we're going to do now is build our visualizer, and I think the visualizer will be really useful for the instrument we're building today because some of the concepts are going to be like time variant, meaning like we're going to create parts of this program that will change over time, and it'll be useful to see those changes. Rather than last week where everything was kind of like instantaneous. Okay, so to get started with the visualizer, going back to the notes here, we're going to use something called a TabRight, which is like another object, and you can read this basically as TableWrite. A lot of things in PD have these like sort of succinct, like words to describe the object just for shorthand. So this is going to be looking at two functions, TableWrite, and then this object called an array. If you're familiar with programming at all, and you've encountered arrays before, they behave pretty much very, very similarly. So we're going to be able to populate a data structure, in this case an array, with values of our signal, and then we're going to display the values of the signal in real time. So pure data is all about doing things in real time, and most programming experiences that you probably have are not in real time. So like things aren't happening live. You make your changes and you run the program. In this case, pure data, the software is running constantly. So everything is running as you're using it. Unless you turn off DSP, things don't work. Things don't provide audio any longer. All right, so like I said, this is going to allow us to visualize signals. It's going to plot like in like a display the value of our signal over time in 2 dimensions. So over time, and it's going to demonstrate the amplitude of that signal. All right, so to create this, so again, and I'm just going to put this away over here. It's still here, but like it's just kind of annoying to keep track of. So if you're following along in the notes, which actually I can totally just zoom in on these, make that a bit easier. So, okay, we're going to make this array that I was talking about. And the way we're going to do that is we're going to go to the top again, the put. And the array is special. It's like its own thing. It's not an object, but it kind of is. So I'm just going to go to the bottom here and click array. When I do that, it's going to prompt me in this window. It's going to ask me like basically what the properties of the array should be when I make it. So I'm just going to call it basically signal. You can name it whatever you want. And then I'm going to give it a size of, in this case, I'm going to say 1000. What this size represents is basically the kind of like the sampling resolution, or basically as our waveform is moving, it's changing over time. We want to capture as much of it as possible to represent in this display. But if we capture too much of it, it will slow the patch down. So it's like a little bit of a trade-off. If you capture too much, it's going to take a lot of resources to recompute every single value of the array, which you can basically just think of it as a list. We're making a big list, a big empty list, and we're going to fill it out. Okay, so that's all we need to do for editing the properties. I just changed the name and the size, and I'm going to hit OK. Okay, so it's going to make this graph-looking thing here. This graph is basically how we're going to, like the way it's presented to us is basically how we're going to use it. Like you can kind of think of this as the x-axis over time, and then this is the y-axis, the amplitude. So we're going to see the signal here. So it's pretty much like suited for this purpose. Okay, So going back to the notes for a second, we talked about the properties. And what we're going to do next, now that we have our array, is we're going to make a TabRight object, so the table right. So this is how we're going to update the contents of the array. Yeah, I would say this stuff, the idea of like, basically taking the signal and saving it in the array, that's about, I would say, all that's super important for this kind of this lesson. It's not too critical to understand, like all the different aspects of how the values are populated and at what rate and things like this. But you can look into that if you want to by looking at the TabRight object. So I'm going to give it a tilde again, and that's because we're working with audio. So I'm taking audio. There's also a TabRight object that is totally valid, but it's not meant for audio. So if I want it to transmit audio to this array, I'm going to give it this tilde. And lastly, what I need to do is provide what's called an argument. So in an object, if I want to initialize an object with some parameter or like a property, I can give it an argument separated by a space. So in this case, the reason I want an argument is because I need to send the content of the signal to this array here. So I'm going to reference it by name. So to do that, I just type the name of the array that I made. So I named the array signal. I'm going to say signal here. So basically, this is saying anything you get at this input, send it to this on the right-hand side. OK, so last thing here, we're basically just going to take this out. So this is the output of our like volume limiter. And that is going to our computer output, but I'm also going to send it to this array here. And that way, it'll display the content of the signal. The problem is that, like, I can go and enable DSP again. So I'm doing that on my end. And we hear the sound, but there's no like content being put into the array. So, something's missing. So what's missing is the bang. So it's basically something that tells this operator or this function, this object, to execute, like to actually write the content to the array. So we're just sending the content to write, but we haven't told it to write to this display yet. So I'm going to turn that off again. It's kind of annoying. So if we go back here, we created our TabRight object, and now we need to create a bang to engage it. So bang is up here again. If you go to this put list, there's this bang option in the dropdown. You can click that, and it's just a button. So we're going to connect the button to this this TabRight here. Oh yeah, okay.
And then we have another question.
Oh yeah.
So do the online to connect us to the
Mm-hmm.
browser.
Mm-hmm.
So you have to create an account or
No.
okay, can you give us a
Oh yeah, of course. Yeah. Yes, yeah. So if we go back, just for those on Zoom as well, if you want to follow along in the browser, because obviously it takes a little bit to set up the desktop. If you go use this link, browser version here from session 1, hopefully it'll load this time because, yeah, great. Okay. So basically it works like the same way as pure data on the desktop, but you just have to make sure to load a new patch just like you would. So nothing's going to happen in here. And it's the same way on the desktop. Like you have to click File and then New. Oh, nice. Okay, cool. Awesome. Yeah, just make sure to click File New, because otherwise you can't do anything. And then once you do, you're good to go. But all the commands and everything like that should be the same. So, all right. I'll just leave it open just in case. All right. So I'm going to zoom out. Well, actually, no, I'm going to stay zoomed in. Okay, so going back to visualizing our signal here. So I mentioned creating this bang. So what this bang is going to do is basically tell the TabRight function to execute, to take a portion of the signal and then to put it into this array. So when I click this, of course, I need to be running DSP. So I've enabled DSP, and you can see here, we see a very pretty looking sine wave. So the oscillator is producing a sine wave at 388 hertz. So if I change that, you'll see it's not updating here. And that's because it has to be banged every single time you want the signal to update. So if I bang it again, you can see the peaks are closer together. That's because I've increased the frequency. If I increase the frequency even more, and I bang it again, we get an even more densely packed wave. You'll also notice that the little contiguous dots are going to kind of be sparse. And that's because we are producing a signal that's like relatively high frequency. And so we're only storing like a certain number of values to represent in here. So it's just kind of not enough. But if we stored more, if we edited the array, which I think I can do, I'm going to turn that off. Oh, I can't. Oh, yeah, I can. Okay, great. So if you double click the array, I think, well, if you double click the array, maybe. Okay, well, I don't know. It worked a second ago, but apparently I can't double click the array right now. I don't know why that is. Hopefully you can on your end. If you can, and it pulls up a little window, you can basically change the size that way. And you can make it bigger and then test that. Whoa. Uh-huh.
So the one that is that's an object or is another?
Oh, yes, it's an object. So I should have explained that. Anything with a square is an object. So you can just add an object and type in exactly what you see here, and you'll get the same thing. So if you go to put at the top and click object, and you can just type in anything that you see in these little squares. This is not a square. It's got this like dent at the top right. So that's a number. So to get that, you say put and then number. And then I'll also introduce messages in a second. So if you hear me say that, a message is just like a little kind of like weirdly indented box, but messages just let you store static values. So we'll get to those in a second. Okay, so you'll also notice that if you draw on the signal or the array, it's actually overriding the values that are stored in there. So I can write manually by hand like 1,000 array values in here if I wanted to. But I'm simply just going to kind of continue. Actually, I'm just going to disconnect the DAC so that we can mess with the wave without like having to hear that sine tone because it's kind of annoying sounding. So yeah, you can see I can just basically keep pinging the bang, and it'll just continuously update the signal. The problem is that anytime we make a change, we have to remember to go back and check for execution again, or like to remind it to execute, to update the array. By the way, yeah, this is, I'm not sure if this is clear, but like TabRight, that's an object too. This on top is a number because it's got the. Oh, this one? Yeah, okay. So this one is a bang. Yeah, so bang is like a special item. So it's just here. Basically, if something comes up and you're not sure what it is, you can usually kind of guess from some of these, but the bang is like a special one. So just in this jump.
When I was first adding objects,
Uh-huh.
I didn't add it as number. I added it as object. How do I delete
Oh,
where?
oh yeah, I kind of have been flying over that. Yeah, so how do you delete? So it's a little intuitive, but you wouldn't think it at first. So you just drag and select everything that you want to delete, and then just backspace. So just backspace or press delete key, either one. But okay, so I'm going to put this bang. Oh, okay, yeah, another question.
So how we make that box the signal box? We are literally using.
Oh, no, that's okay. Yeah, so the signal box. Okay, so this one is unique because, in fact, I'll just delete it and make it again. So that's an array. So it's at the bottom. So when you click it, it's going to open this little properties thing. And then you need to tell it what size you want it to be. So I set it to 1000. You can make it even bigger, do like 2000. And you'll get kind of a better perspective on the wave, but it just gives you fine like resolution or detail, so to speak. So I did like 1000 originally, and then just click OK. So you can see now it's called array 1 because I didn't change the name, but previously I renamed it and called it signal. Yeah. So now you don't have to rename it. Yeah, you can leave it as you want. Oh, if you want to rename it.
Yeah, because we already put this in there.
Ah, yeah, that's what I was trying to figure out. I don't know why.
Really right click the property?
Yeah, is that an option for you?
Yes.
Oh, well then, yeah, that would be the way.
Yeah, but that's and then you have to change.
Oh, well, I would just delete it. It's not worth the trouble. I would just delete it and then put another one.
Or change the right to the right.
Yeah, that works. Yeah, perfect. Yeah, I was about to. So yeah, if I name it something else like the signal or something, and then I say 1000, then what I have to do now is change the TabRight to point at this newly named thing. So now I named it the signal. Yeah, it has to be the same name. It's like you can think of it like a reference. So it's referring to this in particular. And so now I can bang it again, and yeah, we're still getting the updated content. Except for the bang. Okay. Oh, but it won't. Okay, couldn't create. Let's see. Do you have is it giving you try pressing control and clicking the bang, like the little button. Holding control and clicking the bang. Oh, that's interesting. Okay, your signal looks You have to control click the number. You have to control click and drag a number in order to get it to change. So I do like this, like I just like. Okay, that's good. Oh, you got it? Okay, awesome. Yeah. Now I don't know why your array looks so odd. Maybe now you have to control click to bang. You can't. Ah, that looks better. Okay, you're.
Got a low end.
Yeah, you only have one portion of it. Okay.
We see like an orange box instead of like a black box.
An orange box instead of a black box. What?
Yeah, it looks like it's an error or something, but it's not coming up.
Do you mean in here? Like,
No.
oh, okay. I would just delete it.
Doesn't like,
Oh, it doesn't let you.
no.
Okay. Let me let's see if I can hover around briefly. Yeah, no problem. And then you can like make it. Oh, you need a plus. Yeah, yeah. So like if you add, and the wave is like going from -1 to 1.
Yeah.
If you add, then it'll go from -0.8 to 1.2. Like it'll just shift it up. So then if you multiply, it'll scale. It'll scale it down. That's all right. Oh, yeah, you're in the web one. Okay. Yeah. A lot of and the web version doesn't. I don't know why. But it's okay. It won't do it. Yeah, it's just totally fine. Like it will cause no. It's just a weird thing that the web version does.
Unless these numbers
Yeah, that's fine. It's just the audio output. Yeah, the TabRight. Yeah. Yeah, so the TabRight's an object. All right. Okay, so just make sure, by the way, at home, if you're on Zoom, so just make sure that you have this operator, this multiplication here, rather than like a plus or anything else, because then it will change the signal output. Okay, so going back to this, the problem that we have with this patch still is that I have to click bang every single time I want the waveform to like be reflected here. And that's like very annoying because I want to see the waveform at all times. I want it to look like it's like actual kind of like living, breathing audio. So I'm going to set up kind of a weird little function here. Going back to the notes. So I'm going to make a metro object. So again, little square, put the word metro in it. So I'm going to make the square very quickly. And the way I do that is by pressing Command 1. On Windows, you can say Control 1, and that'll automatically prompt you to make a box. And I'm going to type metro in it. So metro stands for metronome. So if you're familiar with the concept of a metronome, like in music, it's like a timekeeper, right? So what? Yeah, exactly. So it's like the kind of the hand going back and forth. And basically, this is going to make a bang, which is going to, like, we're using the bang to say execute. What this is going to do is basically send a bang at some interval regularly, so just forever. So this will be really useful for our waveform view because we can just tell it to constantly update the wave, and then we'll get something that looks like more like audio. All right, so like I mentioned here in the notes, basically the TabRight refreshes the array when it sees a bang, but we would have to click it forever all the time in order to get continuous updates. So the Metro is going to do that for us. So everything in PD is about automating. So like we don't want to do anything manually. We want to do everything in an automated programmatic fashion. So I'm going to take the Metro and I'm going to pass it one argument, just like I did the TabRight. This one isn't going to have a tilde because it's not an audio signal. I'm just sending control. So you can think of it like control signals or control data and audio data are the two things you work with in PD. So here I'm going to pass it some millisecond interval. So I wanted to send, like tell TabRight to execute every X milliseconds. So I'm going to say like 100. So every 100 milliseconds. So like fraction of a second, basically. And what I'm going to do is pass this to the bang. You don't have to pass it to the bang. But if you do, you can see it pinging. So we can kind of get a visualization. And then what I need to do, I mean, you can either pass it to the bang or not, either way. I just made a copy really quick by, you guessed it, Control C. So just real quick, Control C and then Control V, paste it. You can get another one. And I'm going to pass this bang to the Metro. So everything has to execute with a bang. So I need another one to start the metronome. So I'm going to control click here and start the bang. And you can see now the wave, yeah, it's updating regularly. So if I copy this number over here and paste it, I can send it in to this attenuator. So I'm basically going to take another number like the frequency, but I'm going to send it in to this multiplication operator. If you do that, what it's saying is, hey, ignore the argument, like ignore what I would have normally multiplied by and use this. So I'm going to do this because, whoa. I'm going to do this because I want to change it. So I'm going to modify it though before I go changing it. Actually, I'm going to turn off DSP too, because otherwise, it's going to slow down my computer. Oh, dang. Oh, there it is. Okay. Oh, weird. All right, so I'm going to right-click the number, and this is something that's like universally very useful in PD. When you're dealing with audio, again, like you can get to dangerous volumes very fast. So what I like to do is whenever I create numbers, I'll right-click and go to the properties. So again, I'm just right-clicking here. And I don't know why. Sometimes it works. Sometimes it doesn't. I don't know. Hopefully for you, it's easier to right-click. When you right-click, you get this like lower and upper limit. And I like to set the limit to 1 for audio signals. Because if you go above 1, it will scale, you know, to a severe degree. Yeah, upper 1, lower 0. Okay, so now when I click and drag the number to change it, it'll only ever go to 1. Like I can't go above 1. So this is really nice because for audio in particular, it's going to be way too loud if I go beyond 1. Actually, no. Yeah, this is fine. Okay. So from here, what was I trying to? Oh yeah, that's right. Just an extra tip. I know this is getting a little bit like wacky with the keyboard shortcuts, but if you do Shift and Control click, you can move a value slowly. So this is really nice for like if you want like a decimal, like a float value. For audio, it's really nice because we can do like slow, gradual changes. Yeah. So now what I'll do is I need to, it's kind of something I explained in the last session, but the reason this isn't updating the waveform is because basically any input to a PD object other than the first input is not going to trigger a change. It's just represented as kind of like, I'll use this value when I do receive something at my first input. It's kind of the way PD works so that you can really control the flow of data. Because if everything was always updating all of the time, I think things would get a bit more hectic. But with this way, I can control exactly when something executes. So this function here will only execute with this value that I provide on the right once I change its left-hand incoming value. So I have to change this frequency for this to actually do anything. So I can do this like all day. Like it's not gonna do anything to the waveform. But as soon as I change this, oh, I also have to enable DSP. Oh, there we go. Well, now it looks pretty insane. I'm gonna bring this way down. Actually, I just lied about this one. I think it's just gonna change all the time, but sometimes that will happen. So keep that in mind. Anyway, I just forgot to have DSP on. So that's another thing. If like stuff isn't updating and you don't hear any noise, make sure you remember to toggle this little checkbox. So see, it stops and then it goes. All right, so we got as far as basically visualizing this wave. All right, so what I wanted to demonstrate is like how powerful this visualization is. Now I can like reduce the volume and we're seeing going from 0 to 1. And I can change the frequency, make it more dense. And I can make it less dense, get a nicer looking wave. And so now we can kind of do work without like constantly having to hear like a annoying tone or like something like that, like if you're not really ready to listen yet. So I think this introduces a lot of things that like you wouldn't really use necessarily regularly until you got a little more advanced. But at the same time, it's like once you have this, you can just copy paste this whole patch or save it or whatever and just have it forever. And then, if you use PD further, you can just recall this and it's ready to go. So, okay, let's, with the remaining time though, get into more ways to make audio. So going down to the notes, I want to talk a little bit more about like sound or the way you work with sound and pure data, or just general concepts in sound and audio. So we already talked about oscillators, but if you're not familiar with what an oscillator is, or like a waveform or something like this, an oscillator is basically going to generate a moving periodic wave. So that means two things. It means like it's constantly changing. It's changing over time, but also the value over time is periodic, meaning that it's going to hit a value, it's going to reach the value, and it's going to come back to that value at some period, at some interval. That interval is basically the inverse of, or it's inversely related to the frequency of the wave. So basically how often that value recurs, let's say like milliseconds or something like that. If you do like 1 over that, or like 1 divided by that, you get the frequency. Yeah, okay, cool. So, as frequency increases, the time it takes to reach the value again is less, it's decreasing. So we can, you don't have to take my word for it. You can literally yeah.
Lower voice than like
Yeah. So here,
like high value, low value.
exactly, yeah. So I'm going to decrease the frequency. This is the frequency of the oscillator, and it's producing a wave that's like takes a longer time to reach the peak again. And then if I increase the frequency, now it takes less and less time to reach that same periodic value again. So that's the idea of an oscillating wave. You're gonna see like this weird representation here. Like, why is it kind of like almost like, you know, kind of like a barber pole? Like, why is it like sliding like this? This has to do with like phase properties of the wave. The phase is basically where the wave starts. So kind of a weird thing to think about, but if you were to draw a wave, if the wave starts at like max value or it starts at 0, that depends on the phase of the wave. So it's basically describing where in the period it begins. And because of that property, when we write the content of the wave to this array, it like the phase changes over time. Yeah, exactly. Like a guitar pedal, the phase shifter, exactly. Yeah. So what that is doing is basically like filtering or like modifying the content of the guitar, the signal of the guitar with a rotating phase. Like it's modifying the phase over time at like a certain rate. So it sounds like, I mean, the
starting at different places.
yeah, pretty much. Yeah, I mean, yeah. It's definitely like a sub oscillation, but the audio effect is kind of a weird thing to explain too. It's like yeah, phase shifters are very weird, but this is definitely like reminiscent of that effect, I would say, for sure. Okay, so I just wanted to give this like, you know, I think this stuff is like very weird to think about, so I wanted to give like a nice analogy that always worked, like, I mean, since I was in grade school. But basically the way to understand like these sine waves and things like this is if you imagine like a shape. I mean, a circle is like a very simple one to use, and you like draw your finger along it, so something like this. But instead of like going backwards, like when you're about to go backwards, just go forwards instead. Yeah. So basically draw the circle, but only go forwards. And that's literally what a sine wave is. And now you can basically produce any wave that way. So a wave is basically just the contour, like the curve of a shape drawn over time, so to speak. So a square wave, if you've heard of a square wave, you literally would draw a square, but don't go back, just go forward. And then you just draw a square wave. So you can make square waves in pure data too, but I won't show that for now. And we already talked about how all the audio objects in pure data use the little tilde. So if you want to do stuff with audio, use the tilde. And yeah, we're going to make signals using oscillators, so that can be used to produce sound. So this next signal I want to introduce in the last bit of time here. I mean, there's a lot of stuff I wanted to get to, but actually this one's pretty fast. Really quick, we can make, in pure data, we can make noise. So noise is really useful, especially if you want to make sounds that are like drums. Drums are kind of like the basis of a drum is like this noise, this burst. So that one's really easy to do. You just make an object again, and you call it noise. And then a little tilde means that it is going to be audio noise. So click away from that, and then we'll just connect it. And now we have noise. So the noise we can increase too, and it gets really loud. Yeah, noise is basically a randomly occurring value that is not periodic at all. So noise is not periodic. I don't have an expectation of when a value would recur in noise. Like it's totally random when we're talking about noise. There's a lot of research and investigation, and especially today with noise, what's called basically a stochastic process, or like random processes, because I mean basically the world is just noise. Like it's unpredictable. Like so yeah, we need to like be able to understand how to deal with this kind of stuff. So it's pretty interesting subject. There's a lot of kind of like, oh, how does it sound? Yeah, good question. Yeah, it doesn't sound great, but I think it sounds nicer than the tone actually. You could maybe you could like go to sleep to this or something. Yeah, so we can change the volume. Yes, so this is white noise actually. Yeah, so good clarification. So this is actually white noise. The white noise means basically it's often called white noise or Gaussian noise. So the reason is because of this. So, you know, when we talk about noise, we often try to talk about the distribution of values. So the probability distribution of values, meaning the probability that any value is going to occur in that noise. So we kind of want to know that. And white noise in particular has what's called a normal distribution of value across the frequency spectrum. So meaning like, what frequencies will I hear in this white noise? Well, you'll hear an even distribution of frequencies centered around like some frequency. I don't remember exactly what frequency it's typically centered around, but it's like basically the amplitude. If you were to look over like frequency, I mean, you can think of this too if it helps, like in terms of like the scale, if you're familiar with that, like the chromatic scale or something. Yeah, right. So like if 440 is A and then like double that, like 880 is like, you know, an octave up or something like this, then like a really tiny even distribution of noise would look like it's really loud in the middle and then gets quieter at the edges. So that would be like a normal distribution, so to speak. Pink noise is basically the distribution shoved upwards. So it's more higher frequency content. And then I think there's brown noise, and that's like lower frequency content. Yeah. So the distributions are just skewed like they are right here. So this one is like, this green one is like, this distribution is, I mean, it's still a normal distribution because of the shape, but it's like shifted down. Yeah, so you can see here, it's also called Gaussian distribution. And there's multiple normal distributions, like, yeah, okay, cool. So back to the notes. Okay, so I was gonna get to envelopes. I'll try to at least introduce them because I think they're pretty cool. But this is basically last week and this week, you know, we've just been creating these like constant tones. You don't have really like a good way to control like when the tone occurs. Like, you know, instead of it just being constant, we want it to like kind of change or have changes. And this is obviously very useful if you're producing, you know, like sounds for yourself, like music. You know, you'd like change over time. So the way we do this is with something called the line function. I should have said object here. There's just going to be a line object. The way I'll do that is I'll make another object, a little square, and I'll just type line like that. So this is a line object. I'm going to turn this off again. So basically, the line object is going to produce a line. Actually, you can just draw on this array, by the way. So it's kind of nice, like a unique little tool. But the line function is going to make like a continuously changing output that looks like this. This is just going to make a line, basically, a sloping line, a ramping line. And already you can probably imagine like, you know, how this would be useful. Because if I want to control volume, I can have this sloping line just control volume over time, like slope up. So I can make something go louder or make something go softer. So really quickly, I'm going to show you how to create this type of control. So yeah, basically, especially for percussive sounds, by the way, it'd be very useful to like quickly ramp up volume and then drop back off. So the line function takes multiple arguments, and it also has multiple inputs. So remember, arguments are like the space item, so space and then a number or something like that. We could do it like that, but I'm not going to put any arguments here. I'm just going to use the inputs. So the inputs here at the top, these little 3 items. So most of the stuff we've been dealing with only have like 1 or 2 inlets. This has 3. And it's a bit weird, the line function. The first argument is the destination value. So if we were going to control volume, for example, the way I've been doing that is I'm going to turn the DSP back on. But I'm going to nix this sound. So the way I've been doing that is just basically, controlling like this number box here. So that's how I've been doing volume. So what we want is basically a ramp or a line that goes just like this does from, you can imagine from 0 to 1, like linearly. So that's exactly what the line can do. So the first argument being the destination value is exactly what we want to send here. So again, we could give it like this. We could say line like that. But I'm going to put it in the inlet. And I'm going to use a message box. So instead of using a number, I'm going to use a message. And I use a message when I don't really expect it to change. Like it's just a static value. So I'm just going to put a 1 here like that. And this is a message. So in the put dropdown, you can use message. Just drag that like that. All right. And then the second one, that's going to be the time taken for the value to move to that point. So what does that mean? It means like if I want a line that goes from 0 to 1, I'd say, okay, go to 1, and how long do you want me to take to get there? I would pass that into this little inlet here. I'm going to copy that, paste it. And this is also in milliseconds. Most time units are in milliseconds for pure data. So I'm going to say let's say 500, so half a second. That's like reasonably long enough for us to hear what it's doing. Okay, so I'm going to pass that in right there. All right, and then what I'm going to do, actually, I'll just make this bigger. All right, and I'm going to copy this number over here because I'm going to reuse it. So I'm going to put it over here. Also, nice thing about copying stuff, if I can get the right click to work, is it'll keep the properties. So like those numbers where I said you want to limit, like from 0 to 1, if you copy it and paste it, it'll just keep those properties. So it's really nice. Okay, so I'm going to take this line output and send it to this number so that I can see what the line function does. Unlike the audio signal, it's just going to produce a number. So I'm just looking for this number. Now, the way I do this, I can either get another bang like this and send it to this line, and it'll perform the function. But I can also just click the message. So control click it. That'll send the message. You can see it brought it up to 1. But it didn't do it over time as we expected. So if I set it back to 0 and click it again, it just goes straight to 1. And the reason is because this line function is very weird. And the reason I'm demonstrating this is because it's a really annoying thing to debug. So if you know this about it, you keep it in mind. But basically, it only sends, it only sees this value 1 time. And you have to constantly remind it that this value is here. I think they did that because maybe they wanted you to be able to send the line and then send it again differently. I'm not sure. But the best way I've seen to do this is basically send it like this. You can connect these 2 messages. And when you do that, it basically says, when I click this, send the message here and send the message that I'm connected to. So it's like a bang and like a transmitter at the same time. So it's basically like doing taking this bang that we were using before. So if I copy it over here, you'll see if I connect these together, what's happening. So if I put this here at the top of this message, it's just kind of sending it along. It's saying like, hey, I just did something. You should go do your thing too. So if I click this now, you'll see it's triggering this bang. And we have to go back to 0, unfortunately, because the line is going up to 1. So like, well, turn off DSP. So if I'm drawing this again, whoops. Well, why can't I draw? Yeah, so if I'm drawing this again, the line's going up to 1, but then it like stays at 1. So it's like, it's just stuck there. So I have to set it back to 0 for this to work. And it's going to 1. But then it's still forgetting about this value because I'm setting them at the same time. The line object is not great. So lastly, what you have to do is you have to edit this message one more time. And you have to give it 2 arguments. So you have to remind it basically of what it should go to and the time it takes to get there. It's a little bit convoluted to use this object sometimes, but I just want it to be very transparent. That is kind of annoying. Yeah, so let me set this to, so this is saying I want you to go all the way to 1. So start at 0 and go to 1. But now it's more like saying start at 1, and then this is saying now go to 1. Kind of convoluted, but let me just demonstrate it like this. 0. Try that. Yeah, there we go. But I want to go the other way. Yeah, okay. So what this is doing, maybe I should have just done this to begin with, just done it and then explained because it's a little convoluted. But basically what I'm doing is I'm saying, okay, no matter what value the line here is at right now, start with 1. Like that's what this is saying. And then what it's saying is like, okay, next what I want you to do is go to 0 over the course of 500 milliseconds. You have to do this because of the thing I mentioned with the second input. So like if you tell the line to function again, it will just forget that that second input's there. The way you get around that is pass the second input via the first. Kind of a weird thing to do. But nonetheless, it works pretty well. We can even get rid of that little bang and just connect them directly because it does the same thing. So now what we get is this nice output that goes from 1 to 0 very quickly. So what would we do with this? Well, you can pass it to, you can just grab this whole thing, move it over here. Let's just put it all the way up here. And we can drag it like that. And now it's going to change the volume rapidly from 1 to 0. So what does that sound like? If I connect those again, I'm going to connect them, turn on the DSP. So you hear no audio right now. That's because it's forced to 0. And now it does that. So now it's a drum. So it's like a little drum sound. You can hit it, I mean, as fast as you want, I guess. You can change how quickly it emits by reducing this value. So if I edit this to go to 200 milliseconds, it'll go even faster. So yeah, we have a little drum that you can trigger just by clicking this message box. I have a patch that I completed that uses this and a couple other little concepts. So I'll upload it, and if you want to mess around with it, you can like kind of see where this was going. But you know, obviously we went over a lot, so I appreciate everyone sticking around. But yeah, hopefully that was pretty interesting. Sometimes pure data can be a little bit clunky from a UI perspective. I wish they would like improve it, but you know, it's funny because like a lot of people use it, but I don't know, for some reason they just like don't. There's this other software now called, which is just I think it's just because this is so popular, but it's this stuff called Max for Live. If you've ever heard of Ableton, yeah. So this is basically like this software, but like you can use it with Ableton. So basically, you know, if you're not familiar with Ableton, it's like software for creating music. So you can like connect these two things together. And the only problem with Max, it's called Max. Oh, is that the sound? Oh, cool. Yeah, nice. It's called Max MSP, by the way. So in case you're curious, this is like the kind of like professional version, but it's not free. So otherwise I would use this. But, yeah, I guess so. Yeah. Yeah, it looks a lot better too, to be honest. It just like looks a lot nicer, but I do like stuff that's free. Yeah, you can see though, like it's a little bang, same concept. There's a message.
But it's the same language. Like, anything that you know, you do that.
You- Pretty much. There's some caveats and there's some little like, you know, eccentricities that are different between them, but this one is far more popular just because it just got so big. Like, but there's tons of people using this right now, and it's pretty amazing. Like, I would definitely encourage like looking up like on YouTube, like Max for Live performance and stuff, and people like do these whole live performances with the instruments that they make using Max. So it's, I mean, it's incredibly powerful, like really, really cool. But yeah, so I mean, but you know, yeah, again, if this is, you know, same concept. So. Oh yeah, okay. Thanks everyone for joining on Zoom. But yeah, I can stick around for a minute or two to answer questions if anyone has any.